Good afternoon, everybody. For your bell ringer today, you get a notebook check quiz. So your substitute will hand that out to you. You got about 5 to 10 minutes to get it done. You want to find the examples in the notes. And important here, you must show the same amount of work that was done in class. Okay? So if you just write the answer down, you're not going to get full credit for it. You can't work with a partner. You need to do it by yourself. You need to be from your own notes. Okay? So I don't want you borrowing notes from anybody. All right? So look through the quiz there, see if you can find anything in your notes. If you were gone, I just want you to see if you can figure it out, because you need to get the notes when you're gone. And I send them to you so you could practice them as well. All right, so take about 5 to 10 minutes to do that. Pause the video and then start it back up after they're all done. All right, so we'll look at a couple homework questions to see if we have some. I'm thinking a few of them that you might have wanted to look at. 23 for sure. If I show you 23 and if you had problems with the ones before that, you should be able to figure that out. Okay, so let's look at 23 for sure. 23 is this. We have this polynomial. So it's kind of a big one here. And we're trying to prove that x minus 1 is a factor, and we got to keep going from there. Okay? So remember, to prove if it's a factor, we wanted to use synthetic division. So we look here, set it equal to 0, and we get x equals 1. That's what's going in your box. Okay? And then we use our coefficients from the polynomial above. Double check to make sure you have everything you need, like x squared, x cubed. Make sure you got everything, otherwise you might need a placeholder. So then we divide it out. First one drops down, then we multiply by the 1, and then it goes here. And then we add these, remember. Okay, so 2 plus 1 is 3, and then we continue the whole way down. And we do, in fact, get a 0. So what we have left now is this. So this right here would be 1 less power, so that's going to be x cubed. Okay, we have that. We're looking to factor it completely. So you might think, well, I got 4 things there. I'm going to try grouping, but grouping doesn't work, so it's prime. Well, it's not actually prime. We have to list our factors and give it a shot. Okay, so possible factors, we look at the back number and the front number. So it's factors of 3 in the back, so that's 1 and 3, and factors of 1 in the front, so that's just 1. So the possible factors we can try would be a 1, a -1, a 3, a -3. Okay, so we're just looking at the polynomial right here. We're looking at this one right here. We're going to give it a shot, see if we can figure out what it's going to be. So let's plug those numbers in, okay? So if we do a 1, you should be able to kind of look at that and see they're all positive, so 1 is definitely not going to give us a 0. So let's try -1. So plugging in a -1, we would get -1 plus 3 times 1, so that's 3, plus 5 times a -1, so that's -5 plus 3. And that is the one. That gives us a 0. So f of -1 is 0, so that's the one we got to try now. Okay? So let's divide that out. And since we got a -1 in the parentheses there, that's what goes in our box. And we use the coefficients from the one that I have underlined right here. And then we just go through it. First one drops down, multiply by a -1, add, multiply by a -1, add, multiply by a -1, and you got it. Okay, so now we have this broken down. So we have to write this right here into a polynomial. So from what we had before, we had the x minus 1, and then we had this stuff here, but that broke down into this, okay? So now we're going to have an x plus 1 from that -1 in the box, or the parentheses, and then we have x squared plus 2x plus 3 from the coefficients down there at the bottom, okay? Now the x squared plus 2x plus 3, that cannot be factored anymore. So this is your completely factored polynomial. So 18 we have, I'm just going to kind of start right away. We got x plus 2, so that means the negative 2 is in my box. And my coefficients are 1, 2, negative 8. Actually, if I look at that again, we're missing a 0 in there for the x squared. Okay, so that could cause you some problems. We need a 0x squared. Now we got that negative 8. And then minus 16. Okay, first one drops down, multiplied by negative 2, get a 0, multiplied by negative 2, another 0, multiplied by negative 2, another 0. Okay, and then negative 8 plus 0, that's a negative 8, multiplied by negative 2, get a 16, and a 0 on the back end. So that is indeed a factor. All right, so let's turn it back into a polynomial. And this is kind of nice because we got just a bunch of zeros there. So we got x cubed minus 8. So if we keep factoring this, you should see this right here and know that we've done that a ton. That's difference of cubes. All right, so let's expand that one with our factoring. X plus 2 stays out front. This one, that turns into an x. That turns into a 2. That's the little parentheses, and then we do the big one. So that becomes squared here. That becomes squared here. And then the middle is a combination of the two, or multiplication of the two. And then we do same, opposite, always positive. Okay? So there we go. You have to kind of ignore the circle here with around the negative. But that is our complete factorization right there. Those cubes patterns should be kind of starting to stick in your brain. They're not too bad if you practice them. I guess if you just kind of copy down what I write rather than thinking about it, it could be a little bit more difficult. But there's a couple homework problems for you to take care of. If you got more questions on those, you can come and ask me outside of class or in the morning. Okay, so let's get started. You can turn your homework in, make sure your name's on the top, and then we'll get started on the new stuff. All right, so we're doing 4-9 today. All right, so this is the last section in Chapter 4. You'll have a quiz over Chapter 4 in a day or two, probably a couple days. We'll have it tomorrow. All right, so see if we can figure this stuff out. So roots and zeros. So thinking of what roots and zeros are, they are pretty much the same thing if we talk about them, okay? Roots and zeros, you kind of think about zeros when you solve, you get a 0. Roots are more like when you're looking at a graph. How do you figure out where the roots are? Okay, so what are they when we're looking at a graph? So this is in your book. It's a whole bunch of stuff, and you don't really need to write anything down from here. It's got the polynomial up there at the top, and when we're looking at a graph right here, x-intercepts and roots and zeros, okay? They're all the same thing. So that graph right there would have 4 of them. We don't care about y-intercepts when we're talking about zeros. We just only care about x-intercepts, okay? And looking at this polynomial, whenever we have these roots here, so this is a negative 3, that's a negative 2, that's a 1, and that's a 2. We can rewrite those all as factors. So if I wanted to write this one, that's x plus 3. If I wanted to write this one here, that's x plus 2. If I wanted to write this one, that's x minus 1. If I wanted to write this one, that's x minus 2. And we could actually figure out what the function looks like just by multiplying that all out. Now we're not going to, but that's pretty much roots and zeros in a nutshell. Okay? So let's figure out the number and type of roots here. We're going to find the zeros, and we're going to kind of identify them and classify them. We're going to say what kind they are, which would either be real or imaginary. Okay? Not too complicated. So looking at example 1, we have that polynomial, okay? How do you factor that? Shouldn't be too terrible. So we got our 2 parentheses, and then we got an x in the front and an x in the front there. 2 numbers that multiply to give us 48 and add to give us 2. Well, that'll be a 6 and an 8, okay? So 6 and 8, so we got to figure out which one's positive. If we're looking for a plus 2 in the middle, then that means we're going to have a positive 8, negative 6. And we have it equal to 0, so we still have to keep going. So We factored, and now we're going to go to the next step and solve. So to solve, you set each piece equal to 0. We've done it quite a bit. All right, set that one equal to 0, set this one equal to 0, and then get your two answers. So the first one there, you add the 6, and we get x equals 6. Pretty simple, right? Second one, we minus 8, and we get x equals negative 8. So those are our answers to state the number and type of roots. So these would be two real roots, or two real zeros. And you could go the roots, it's spelled roots with a Z. You could go the next step if you wanted to and say that we have one positive and one negative, but it's really not necessary. We're looking for the number, so that would be two of them, and you're looking for real or imaginary. Okay? So however you want to describe them after that, that is fine. Negative, positive, whatever you want. Okay? So let's look at the second example here, and then I'll have you try a couple on your own. So we have y to the fourth minus 256. Well, we only have a couple patterns that we know for something when there's only two terms. Okay? So the number one pattern that we're probably going to be using is difference of squares. Difference of squares. So we'll have y squared in both of them. And then remember how we get our number from this. You take the square root of that. Okay, square root of 256, that should be 16. So y minus 16, y plus 16. Okay? So from there, if you wanted to, since they're both squares, since we're down to a square, you can take each of them and set them equal to 0. I want to keep going a little bit because I think it's easier to factor than it is to make two equations. So this one changes to y minus 4, y plus 4, because that is another difference of squares pattern. And then we just have that y squared plus 16. That's the one we're going to have to set equal to 0 regardless. So this one's going to give us a y equals 4. This one's going to give us a y equals negative 4. And this one, let's make our equation. Y squared plus 16 equals 0. So subtract 16 from both sides, and then we're going to have y squared equals a negative 16. And then you square root both sides. Okay, to get rid of that square. Don't forget, when you square root both sides, you have to have a plus or minus. But this will turn into plus or minus 4i. So those are the four solutions for our problem. Okay? Remember, you can double check exactly how many you want or how many you need in the end because it's the fourth power. So then we just need to explain the number and type of roots. Okay, that's the next step here. 4 roots here, and we just need to state the number and type of roots. So we got 4 of them there. We got 1, 2, and that plus or minus 4i gives us 2 more. So there are 4 roots. All right, so to state the number and type, we have 2 real roots, and we have 2 imaginary. Okay, that'd be the extent of it. We'd have to find them and then just state how many of each we're going to have. 2 real, 2 imaginary. And remember, again, I said you could do 1 positive real, 1 negative real, 1 positive imaginary, and 1 negative imaginary if you wanted to go further, but it's not necessary. All right, so I want you guys to try these next 2, so please pause the video for about 3 to 5 minutes and have the students work through these 2. All right, back at it. So we have this top one here. We're going to factor that. So we need an x in the front of both of those, and 2 numbers to multiply to give us a 12 and add to give us a 1x. All right, so that would be a 3 and a 4. And we want the 4 to be the negative because that middle number is negative. Okay, so that's the way it factors. We get our 2 answers. We get x equals 4, and then we get x equals negative 3 from those. And again, if you remember how to get those, you have to set each chunk equal to 0. So set that equal to 0, set that equal to 0, then solve, and you'll get those 2. So that's 2 real roots. And the one down here is going to take a little bit more work. Okay, so we have a to the 4th minus 81. So we have perfect squares going on here. Okay, we should recognize that 81 is 9 times 9. or it's a fourth power of 3, but we don't have a pattern for a fourth power. All right, and then we should recognize that a to the fourth is a squared times a squared, so we set it up like this. All right, so we have an a squared, and we're going to have minus 9 plus 9. And then you got to look at it again, see if you can keep going. Right here, that's difference of squares again, so we have to keep going with that one. All right, so that would turn into a minus 3, a plus 3, and then this one right here doesn't break down anymore, so you just have to leave it as a squared plus 9. And then we're actually trying to find our roots here. All right, so this one gives me a equals 3, just set it equal to 0. That one gives me a equals negative 3. And then this one, you should kind of be able to visualize it now. We're going to have a equals plus or minus 3i. All right, I'll just write it off to the side here to show you. A squared plus 9 equals 0. Move the 9 over. A squared equals negative 9. Then you square root both sides, and we arrive at this answer. Okay, it's number and type of roots. We got 2 real. I'll just write the lazy r. And then we have 2 imaginary roots. That would be as good as we need. So that's finding the number and type of roots for those. And we actually found the exact roots. Okay? So there's a way that we can kind of narrow down what kind. So first of all, the corollary to the fundamental theorem of algebra. I've been kind of talking about this the last couple of days. It's pretty much how do we know how many answers or how many roots we're going to have. So you find the degree, or the biggest exponent there. So it's x cubed. So this is the 3rd degree. You're going to have 3 roots. Here, 4th degree, you're going to have 4 roots. And then all the way down here, 5th degree, we're going to have 5 roots. Okay? And then the next thing I'm going to show you is called Descartes' rule of signs. We're not going to kind of get into the entire thing here. I'm just going to kind of show you a little bit of what it does, and then we can kind of use it if we need to. Okay? So we're going to count the number of sign changes and the coefficients of our function. All right? So that would be looking for something going from positive to negative or negative to positive. So whatever that is, so this is the number of positive zeros or less by an even number. So that means if we count up 4 sign changes, all right, so if we have 4 of them counted up, we saw that function go from positive to negative 4 times. That means we could have 4, 2, or 0 positive answers. Okay? And then this right here, so the negative version of that, you're just going to flip all the odd exponents to a negative, or if it's a negative, you're going to flip it to a positive. Okay? And then the same kind of thing applies there. So I'll just kind of show you how it works here. So we're just going to look for the positive real zeros. I'm not going to look for negative and imaginaries. So this is my function here. And we're just going to count sign changes. So as I go from there to there, that goes to negative to positive. That's 1 sign change. Here we go from positive to negative. That's another one. Negative to negative, negative to negative. So we only have 2 sign changes. All right? So this is going to tell me the amount of possible positive real zeros. So we could either have 2 positive zeros, or we could have 0 positive zeros. Okay, because we just count our sign changes and it's going to be either 2 or 0. So you got to go down by an even number. For the negative one, you're going to change your odd exponents. So that would be this one, and then you're going to do exactly the same thing. Okay, you just count your sign changes, however many you have. It could be 2, it could be 1, so it would be less by an even number. So kind of like this, if we have 2, you could have 0, all right, because 2 minus 2 is 0, that's less by an even number, okay? It's kind of useful in only certain case scenarios, so I'll kind of show you later on here. So for these 2 right here, let's just kind of do the top one. This should be reviewed from yesterday, or from 4-8. Okay, so find all the zeros of that. Essentially what this is saying, and we could actually do this a little bit easier than I thought, essentially it's saying factor and solve. That's finding the zeros, okay? We have 1, 2, 3, 4 terms. Okay, and you should see 4 terms and something should click in your brain that says factor by grouping. That's the first thing you want to try. All right, so grouping, you split it in half. Then we look at the front half, which we can take out an x squared, get x minus 1. And then we look at the back half. Okay, so we got 2x plus 2. So this is kind of a non-example of grouping because you should recognize that we can't really do grouping. In order for us to do grouping, we have to have the same thing here as we do here. Doesn't work. So we're on to the stuff that we learned yesterday, or 4-8, where you have to do that rational zeros theorem. All right. So rational zeros theorem, remember we look here. And we look at the number in front. So coefficient in front is a 1. And then we have to list our possible zeros. So factors of the front number, 1, 2, or actually factors of the back number, 1, 2, 4 over factors of the front number, which would be a 1. And it's either positive or negative. So then we just list our numbers from those possible combinations, which is 1 over 1, which is just a 1. 2 over 1, that's a 2, 4 over 1, that's a 4. And they can be positive or negative, okay? So remember what I said to do with those numbers now. We have 6 possible combinations. We are going to try them all. So f of 1, try that. F of negative 1, f of 2, f of negative 2. Or I'll just write those out. We'll see if we hit one there. So if I plug a 1 in, I'm going to get 1 cubed, which is 1, minus 1 squared, which is 1, plus 2 times 1, which is 2, plus 4. That's not it. Okay, that one's out. Try negative 1. So negative 1 cubed, negative 1. And negative 1 squared is a positive 1, but we have a minus in front of that, so that stays like that. 2 times negative 1 is negative 2, and then we just have that plus 4 on the back end. So we got negative 1 minus 1, which is negative 2, minus 2, which is negative 4, plus 4, 0. That's it. Remember we say huzzah when we find the 0. That's the one we're going to use. Okay? So let's do it. So negative 1 goes in my box. Then I have coefficients 1, negative 1, 2, and 4. All right, drop the first one down, gives me a 1. And then I multiply by the negative 1. Which gives me here a negative 1, and then we just add those, okay? We should be fairly good at synthetic division by now. So we have a negative 2, multiply it again, gives me a positive 2, 4, multiply by the negative 1, we get a negative 4. And we did get that 0 there just to kind of double check. So now we have, let's move some stuff out of the way here. Oh, we can't do that. There we go. So let's move some of this stuff out of the way so I can rewrite it like a polynomial. So we got this one, that minus 1, so we have to rewrite that as a factor, which is this. And then we have this stuff here. So this would give me an x squared minus 2x plus 4. And we are looking for roots or zeros, so we have to go from there. All right, so then we try to factor it again. Does this stuff right here, does that continue to factor? You've got to ask yourself 2 numbers that multiply to give you a negative or a positive 4 and add to give you a negative 2. Well, your options would be 2 and 2. They multiply to give me a 4, but they're either going to give me a 4 or a 0. And the other option would be 4 and 1. So that's either going to give you a 5 or a 3. So that method is kind of out. So we did some problems like this yesterday for the homework. If you can't factor it, then you're left with the quadratic formula. So that's negative b plus or minus square root b squared minus 4ac all over 2a. So we're going to have to try to get our zeros from that. This one right here is pretty easy. X equals negative 1, that's a 0. This one right here, we're doing the quadratic formula, so that'll take us a little bit of effort. So plugging our a, b, and c in. So that would be a 2 plus or minus b squared, which is 4, minus 4 times a times c, all over 2a. Simplify that down a little bit. So this is going to give me a 16 here. So 4 minus 16 is a negative 12. We actually did one just like this previously. So this would give me square root of negative 12 all over 2. So square root of negative 12 is 2i square root 3. And then remember the last step to simplify, we have 2's and everything, so let's take those out. So this will give us 1 plus or minus I square root 3. Okay, and if we were to list the type of zeros here, we would have 1 real, 2 imaginary. Okay, so let's try the second one here. So see if you guys can handle that one, see if you can give it a shot. It might be very similar to this one. So please pause the video, give them 2 or 3 minutes to try that example, and then start it back up again. Okay, to double check what we just did here, rational zeros theorem again. So it's exactly the same factors as what we listed above. Okay, so I'm not going to rewrite them out. Plus or minus 1, 2, 4. So we have to try f of 1, f of negative 1, f of 2, f of negative 2. You try those until you get one. All right, I'm just listing them all out so that way we can check them off as we're done. So if we do a 1, so 1 cubed is 1, minus 3 squared, or 3 times 1 squared, that's still a negative 3, minus 2 plus 4. So 1 minus 3 is negative 2, negative 2 minus 2 is negative 4, and that one right away, huzzah, we got another 0. Okay, so we don't even have to worry about the other ones. We don't need them because we found our 0 already. So let's do our synthetic division. 1, negative 3, negative 2, positive 4. Draw your line. First one drops. Then we multiply. Multiply. And multiply again so we get a 0 back there. And this is pretty much the same situation. X minus 1. X squared minus 2x minus 4 equals 0. Okay, and we'll just go through this one quick so we can double check our answer. That gives me an x equals 1. Quadratic formula here, we get 2 plus or minus square root of 4 plus 16 over 2a over 2. So this one we continue simplifying, that's square root of 20. So that would give me a 2 square root 5. And then we can simplify that down by taking the 2's out. So we're going to have 1 plus or minus square root 5. Okay? So that would be our solution. All right? So hopefully that made a little bit of sense. The quadratic formula just kind of adds a little bit more difficulty to this, I suppose. Because factoring, you guys know, is a lot easier than using the quadratic formula. All right? So on to the next step here. So this is really working backwards from what we just did, okay? So we worked all the way through factoring, rational zeros theorem, whatever you want to do, to get your answers. So these right here are actually like our solutions, or they're like factors. So we got to figure out how to rewrite it. So if I get a 1 as an answer, I should know that if I had parentheses, that was going to be an x minus 1, right? So if I kept thinking forward here, like, oh, set that equal to 0, I get an x equals 1. So we're just kind of working backwards from that. You're given the solutions, turn it back into a polynomial. So this one gives me an x plus 2, and then this one is going to give me an x minus 3. Okay? Now that's not a polynomial in standard form. Okay? That's just 3 factors written out one after the other. So to get it in standard form, you're going to have to multiply this all out. Okay, so remember we do these 2 first. Whatever we get from here, we multiply it by that one. So let's give it a shot quick. Foiling these 2 out here, we're going to get x squared plus 2x minus 1x minus 2. And that's going to simplify down to, I'll write it up here, x squared plus 1x. I'll just write it as an x. Minus 2, and we're going to take it times that x minus 3 that we have there. Doesn't matter where you write the x minus 3. If you put it off to the right, put it off to the left, it doesn't matter. Okay, so x is going through, That's going to give us x cubed plus x squared minus 2x. And then the negative 3 is going through. So that's going to give me a negative 3x squared. Remember, it's best to write it underneath the same term, same power. Negative 3x plus 6. Combine like terms, and then we are done. So 1 minus 3 is a negative 2x squared minus 5x plus 6. So that is the function that I actually started with. So if you wanted to work backwards and double check, you can do rational zeros theorem all over again, and you should end up with 1, negative 2, and 3 for your answers. A lot of work? Yeah. So make sure you get it right the first time. So whenever we end up getting imaginary numbers, there is something called the complex conjugates theorem. And you guys remember conjugates by simplifying stuff like this. All right, so remember we needed a conjugate to simplify that. So this is what a conjugate looks like. All right, now that's not what we're doing, but we're going to have to use the idea of the conjugates. Okay, so if we have a plus bi or something plus an I, you also have to have a something minus an I, so a minus bi. Okay, complex conjugates theorem. You're probably just going to be given one of these, so I have to know that they come in pairs, so I'd have to make that one up. Okay, and I'll show you what it looks like, and then we should be close to done here. All right, we'll just do one of these and call it good, because that is the last slide. All right, so write the polynomial function in standard form. So we're given this 0 here and that 0 here, that imaginary number. So conjugates, since I got a negative 3i, then I'm going to have a positive 3i. Okay, just because they come in pairs. So I got 3 zeros here. Okay? And then same kind of idea as before. Write it as a bunch of factors. So we got x plus 1, and then we got x plus 3i, and then we're going to have x minus 3i. A suggestion here, always start with the imaginary numbers. Okay, you always start with your pair of imaginary numbers. So that would be these two right here. It's going to make your life way easier. If you don't, then you're going to be multiplying for probably another 60 seconds in comparison to people to remember. Okay, so let's do these two first. So that's going to give us x squared minus 3ix plus 3ix minus 9i squared. You should kind of see the reason why I've multiplied those first. These two terms right here in the middle are going to cancel. Positive and negative 3ix. They just add to each other and they're gone. Okay? And then 9i squared, negative 9i squared. You have to remember, I squared equals to negative 1. So that means this is going to flip to a plus 9. So after I multiply those two imaginary numbers, I have something that's fairly simple. I just have x squared plus 9. Because those center terms canceled out and that negative 9 turned to a positive 9. Now you have to take that and multiply it by the x plus 1 that we had left, and we're done after that. So this is FOIL down here. First outer, inner, last. So we're going to have x cubed plus 9x, right? That's this one through. And then we're going to have x squared plus 9. And then we just need to combine like terms, write it in decreasing order, and you are finished. Okay, so the biggest power, x cubed, next in line, x squared. After that, 9x, and then the 9. That is our polynomial in standard form. That's our function that we're trying to find. Okay, hopefully that made a little bit of sense, because we need those imaginary numbers in conjugates. Okay, you have a few problems like that on your homework. So here's your homework. Give it a try. If you guys are stumped, you can either go to your textbook resources and watch some videos. You can probably find something similar on there. Or you can send me an email. I don't care. I'll probably be at the track meet and be busy, but tomorrow night I can probably answer some emails. So give it a shot. Let me know what you think when I come back. Good luck.